Welcome geometry students to the homework help video. Excuse me, page 147, 2 through 16, and 19 through 21. Please go ahead and open your books to page 147, and let's go ahead and get started with these. Hopefully you're not just copying down what I'm saying. I hope that you're really listening and learning here, okay? Let's start off with numbers 2 and 3. The directions for 2 and 3 state, using the given information, state the theorem that you can use to conclude that R is parallel to 3. All right, here we go. Excuse me. R is parallel to S. So, look what they give you, students. They tell you that R is parallel to T. So here's R. R is parallel to T. Okay? Then they tell you T is parallel to S. So T is parallel to S. Now I guess I really did not need to draw all those arrows, but here's the thing I want to show you. R is parallel to what line? T. S is parallel to what line? T. We have a theorem that says this: if two lines are parallel to the same line, then those two lines are parallel. So how do I know that R is parallel to S? Because R is parallel to what line? T. S is parallel to what line? T. And we have a theorem that states whenever two lines are parallel to the same line, those two lines are parallel. Now, if you want to save time and just write the number, then you'll have to look in your notes. But you'll see in your notes you could put TH 3.11, because theorem 311 says if two lines are parallel to the same line, then they're parallel to each other. Number 3. Now look, students, R is perpendicular to T, and S is perpendicular to T. Do you see that? R is perpendicular to T, S is perpendicular to T. We have a theorem that says this: if two lines are perpendicular to the same line, then those two lines are parallel. So R is perpendicular to T, S is perpendicular to T, so S and T are, R and S are perpendicular to the same line, T. So we can definitely state that R is parallel to S, because R and S are perpendicular to the same line. And if you want the theorem for that, I would write down theorem 3.12. All right, let's continue on. Let's take a look now at numbers 4, 5, and 6. The directions for numbers 4, 5, and 6 say, using the given information, state the postulate or theorem that allows you to conclude that J is parallel to K. All right, here we go. Now watch. Please watch this, students. J is parallel to N, and K is parallel to N. So J and K are parallel to the same line, N. Thus I can state J is parallel to K, because they're both parallel to the same line. And that would be theorem 3.11. Look in your notes and you'll see that. Theorem 3.11. Okay, number 5. J is perpendicular to N, and K is perpendicular to N. So J is perpendicular to N, K is perpendicular to N. So I can definitely state that J is parallel to K. Why? Because J and K are both perpendicular to the same line, line N. And the theorem number for that, excuse me for yawning, I apologize, is theorem 3.12. Now let's take a look at number 6. Number 6 is going back a couple lessons, I believe, okay? How do we know that J is parallel to K? Well, look what they give you right here. They tell you that angle 1 is congruent to angle 2. Now you know, students, how I like to, well, I shouldn't have done that probably. Hold on one second. I'm just going to erase that, but it's not what I wanted to do either. And this is not good. Okay. Wow, I'm having all kinds of problems here, aren't I? All right, hold on one second. Okay, I am back. Sorry about that. Okay, number 6. You know how I like to grab this thing and turn it so that the parallel lines are running left to right? Well, now that I've done that, do you not see these two angles here are called alternate interior? Okay, we know they're on the interior because they're in between the two parallel lines, and we call them alternate because they're on opposite sides of the transversal. So why can I state, or how can I state, that J and K are parallel? Because we have alternate interior angles that are congruent. There you go. That's the reason why. Now, I know you didn't give me the exact postulate or theorem number, but this is fine. Alternate interior angles are congruent. Okay? Now, number 7 through 12, the directions state, explain how you would show that C is parallel to D. State any theorems or postulates that you would use. Okay? So, here we go. Let's take these really, really slow. Number 7. Well, first of all, you need to understand that this angle here and this angle here, they're both on the left side of the transversal, and they're both above the two parallel lines. We call those angles corresponding angles. And one of the 6 ways to prove that two lines are parallel is corresponding angles are congruent. So that's all you got to write. You're done. Corresponding angles are congruent, thus C and D are parallel. Do I need to go over those 4? I want to list those 6 ways real quick to prove that parallel lines are parallel. Alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. Consecutive interior angles are supplementary if two lines are parallel to the same third line, and if two lines are perpendicular to the same line. Okay? Those are the 6 ways to prove that two lines are parallel. All right, number 8. Now think about this carefully. Here's your 2 lines cut by a transversal. Look, guys, this angle here and this angle here, they're on the exterior, and they're on opposite sides of the transversal. So we would say alternate. How do I know that C and D are parallel? Because I have alternate exterior angles congruent. That's one of the 6 ways to prove that two lines are parallel. All right, number 9. Well, again, you know me, and hopefully I won't mess this thing up and like the last time. I'm going to run my parallel lines just like that, so they're going left to right. Now, look at these angles. This angle is going right here. This angle is referring to this right here. Look, students, they're on the inside, they're interior. They're on opposite sides of the transversal, so they're alternate. So look what we have. We have alternate interior angles. Alternate interior angles are congruent. And that's one of the 6 ways to prove that two lines are parallel. Alternate interior angles are congruent, thus C and D are parallel. All right, number 10. Now this is a little harder to see. This is 85 here, and this is 95. Now, again, you know me. I'm going to do this all year long, and I'm not sure why I did that right there. So, oh well, too late now. I'm just going to erase it. There we go. But I want my parallel lines to run left to right, so there we go. Now, look. What's the name of these two angles? They're called same side interior angles, or consecutive interior angles. And one's 85 and 90, and one's 95. Well, guess what, students? If you add 85 plus 95, you get 180. So how do I know that C and D are parallel? Because my consecutive interior angles are not congruent. No, they're supplementary. Whenever your consecutive interior angles are supplementary, then the two lines that are being intersected are parallel. So C and D are parallel. Okay, number 11. Now look, students, C is perpendicular to N, and D is perpendicular to N. So C is perpendicular to N, D is perpendicular to N. So we have a situation where we can state Theorem 312. Theorem 312. Remember what Theorem 312 says? If two lines are perpendicular to the same line, then those two lines are parallel. So if C is perpendicular to N and D is perpendicular to N, then C and D must be parallel, and the reason is Theorem 312. All right, let's be very careful here. Let's take a look at number 12. All right, number 12. Now there's the two lines that are supposed to be parallel. Be very careful here with what you're doing. I would like to totally, if I can, get rid of this line right here, students. I don't even need this line. That line is doing nothing right there, in my opinion, except confusing me. So here's what I'm going to do. I'm going to take this and this, and I'm going to draw a line like that, good, and a line like that, good, and a line like that, good. And I'm going to grab this picture, and I'm going to go ahead and take my ink here, and I'm going to put 116 degrees here, and I'm going to put 64 degrees here. And now watch what I'm going to do. I'm going to yank this picture totally out of the way. I don't even want this picture there. There. Now you know what I did? I got rid of this line right here. I got rid of that line right there. Okay? So let's pull this picture out of the way, and you're going to see how much easier it is. Look at that. Boy, that's a lot easier now, students. I mean, think about it. What's the names of these two angles right here? Well, they're called same side interior angles, or you can call them consecutive interior angles. And if you add 116 plus 64, you get 180. So how do we know that these two lines right here, this line and this line, how do we know those two lines are parallel? Because my consecutive interior angles are supplementary. Okay? And that's a really big help. Okay? All right. That was number 12. Let's move on now to numbers 13, 14, 15, and 16. Okay? The directions for those problems state this. Determine which lines, if any, must be parallel. Explain your reasoning. Now, this is really good because now you don't know if they're parallel, and you've got to decide if they are and why they're parallel, and etc., etc. So this will be really good, okay? Excuse me again for yawning. I apologize. And here we go. Let's start with number 13. Number 13. Now, number 13 is going to be really interesting, so I hope you'll give me your undivided attention here. It's going to be very, very interesting, okay? Now, watch carefully what happens here. First of all, I'm going to take my pen, and I'm just going to go ahead and write over this. This is 80 degrees, and this angle right here is 100 degrees, okay? And we can see this angle here is congruent to this angle here. Now, please watch this, dude. This is so cool. Please watch this. By the way, this is line P, this is line Q, and this is line R, okay? This is line S, and this is line T. Very good. Now please watch what happens here. Look, do you see how I have this line here and this line here? Do you see that? Watch, cut by this transversal here. Do you see that? Okay? Now why is that important? Well, I'm glad you asked. Here's why. Look at these two angles. Those are my consecutive interior angles, and they're supplementary. So, if this angle here and this angle here is supplementary, then I can state that R is parallel to Q. This line here and this line here are parallel. Why? Because consecutive interior angles are supplementary. Okay? Now, watch this. Do you see how this angle here is congruent to this angle here? Now please watch why that's real important, okay? Hopefully you've already copied down what I had written there off to the side. Now, this line here, do you see it? Q, and this line here, P, do you see it? Is cut by transversal T. Okay? And when that happens, look, this angle is congruent to this angle. Well, guess what? These two angles are called corresponding angles. You know that. They're called corresponding angles. So I can state that Q is parallel to P because corresponding angles are congruent. Very cool problem so far. Now, what did we state earlier? Just a little bit ago, we stated that R is parallel to Q. And now we're stating Q is parallel to P. Look at this, guys. Look. R is parallel to what? Q. We stated that earlier. P is parallel to what? Q. So R and P are parallel to the same line. So now I can state that R is parallel to P. And what's the reason? Well, it should be theorem 3.11. 3.11. Whenever two lines are parallel to the same line, then those two lines are parallel. Wow, so we did a lot on this problem. That was really good. Okay, number 14. Now, on number 14, I'm going to drag this down here. Let's turn it like we always do. And now let's see what we got. Now, notice I have this line here and this line here cut by this transversal right here. Do you see that? And notice I have 2 marks here and two marks right here. Do you see that okay? So I'm going to grab this picture and pull it out of the way. And that's what I have. Look at that. So I have 2 lines right here. 2 lines cut by a transversal, and this angle here and this angle here are congruent. But guess what? Those are called corresponding angles. So if I have 2 marks here and 2 marks here, that means my corresponding angles are congruent. So this line here and this line here are parallel. Now, what's the names of those 2 lines? It looks like I and J. No, J and H. J and H. So I can definitely state right now, right here, I can state that J is parallel to H by what reason? Corresponding angles are congruent. Now, I'm not sure if we're done yet. We might be, we might not be. Let's take a look at this. Now, let's take this back over here. Now, I want to take this, I want to turn this picture around. I want to show you something else. Now, this is interesting here. Look what I have. I have a line here, okay, and a line here. Do you see that? Now watch this. Cut by a transversal. And notice I have 1 mark here for congruent angle and 1 mark here. Now I'm going to pull the diagram out of the way. Now, students, some of you would like to state that this line here is parallel to this line here. You can't. Do we have a name for this angle here and this angle down here? No. Now, if they would have said this angle here is congruent with this angle here, then we have alternate interior angles. If they would have said this angle here is congruent to this angle up here, then we would have alternate exterior angles. But we do not have a name for these 2 angles that are congruent. These 2 angles that are congruent, this angle here and this angle here, they are not alternate interior, they are not alternate exterior, they are not corresponding, and they are not consecutive interior. They are nothing. So you cannot state that this line here is parallel to this line here. You cannot. So this is the only thing you can state right here. Okay, let's take a look at number 15. That's a really bad drawing, and I apologize. Let's see what we got here. This is a right angle, and this is a right angle here, and this is a right angle here. Now, let's go ahead and get a little better description here. This is A, this is line B, this is C, and that's D. Now, do you see something here? Do you see line A? Do you see how line A is perpendicular to D? I'm going to write that down. A is perpendicular to D. And do you see how B right here is perpendicular to D. Do you see that? Right here they form a right angle. So B is perpendicular to D. Now guys, look. A is perpendicular to D. B is perpendicular to D. A and B are perpendicular to the same line. So I can state that A is parallel to B by theorem 3.12. Okay, very cool. Now, we're not done yet. All right, take a look at this. Again, we have line A, line B, line C, line D, right angle, right angle, right angle. But let me show you something else. Do you see how line D forms a right angle right here with A? So I can definitely state that A is perpendicular to D. But now look at this. Do you see how C right here forms a right angle right here with A? So I can state that C is perpendicular to A. So look, if C is perpendicular to A and D is perpendicular to A, then C and D are perpendicular to the same line, so I can state that C is parallel to D, and that would be theorem, again, 3.12. Whenever two lines are perpendicular to the same line, then those two lines are parallel. All right, so pretty good. Now let's take a look at number 16. Sorry that it's a little blurry there. All right, let's continue. My speaker's getting hung up here on my chair. All right, there we go. Okay, now I'm just going to tell you right now, you cannot prove that any of these lines are parallel. You can't, Mr. Earhart? No, not at all. Look, I know. I'm going to go ahead, and I apologize for this being blurry. I should have taken a better picture of this, but real quick here. This is A, this is B, this is X, this is W, and we have a right angle here and a right angle here. Now look, we know that W is perpendicular to A because they form a right angle right there. So we can see that W is perpendicular to A. And then we see that this line right here, X, forms a right angle with B. Right there's the right angle. So we know that we can state that X is perpendicular to B. But look, we don't have two lines perpendicular to the same line. We have W perpendicular to A and X perpendicular to B. Also, we don't have anything like corresponding angles or alternate interior angles or alternate exterior angles or consecutive interior angles. We have nothing. So you cannot state for sure that any of these lines are parallel at all in number 16. You really can't. Okay, let's take a look at numbers 19 through 21, and we're finally finished. All right. The directions for 19 through 21 state, find the value of X so that G is parallel to H. G is parallel to H. Well, look, if G and H are parallel, here's G and here's H. Okay, if they're truly parallel, then if there's 90 degrees here, there also would have to be 90 degrees here, which would mean 90 degrees here. So this 7x plus 13 must equal 90 degrees. Now we're going to subtract 13, and we will get 77, and then divide both sides by 7, and x equals 11. That's number 19. Okay, now please look carefully, students. Don't miss this. And I think this is a problem here where I probably annoy you a lot doing this, but I think it's very important that we do this. Now look what we have. We have two lines right here cut by a transversal. Notice we have this angle here and this angle here. They're on the interior and they're on the same side of the transversal. So we call these two angles same side interior angles or consecutive interior angles. And do you remember when two lines are parallel, your consecutive interior angles are supplementary. They're not congruent. Please don't take 9x and set it equal to 8x plus 10. No. Your consecutive interior angles are not congruent. Your consecutive interior angles are supplementary when these two lines here are parallel. So I've got to take my one angle, 9x, and add to it my other angle, 8x plus 10. And when you add those two angles together, you should get 180. So 9 plus 8 would be 17x, plus 10 equals 180, and then subtract 10 from both sides. 17x equals 170, and then divide by 17, and you will get 10. So x equals 10. And finally, the last problem. We're all excited about that. I think it will help again to turn this just a little. All right, now look what we have here, students. Be very careful. Watch. Okay. We know this is 90 degrees. Now, if these two lines are truly parallel, all right, if these two lines are parallel, if this is 90 degrees right here, then what is this right here? Isn't this also 90 degrees? Sure, definitely. Definitely it is. Now watch this. Whenever two lines are parallel, corresponding angles are congruent. This angle here and this angle here are corresponding angles, so they're congruent. Whenever two lines are cut by a transversal and those two lines are parallel, we know their corresponding angles are congruent. So 15x equals 90, and we're going to divide both sides by 15, and x equals 6. Call me, email me, get help from me if you need to. I am here to help you. Please continue to work hard on your homework, and call me if you have any questions.